is it a function? If so, what is its domain? So we have two of these are written in function notation. So when you write things in function notation, you have the function name and then the name of the independent variable. So my function name here is g, and my independent variable is x. Because this is written in function notation, I can be pretty certain that yes, this is a function. So what is its domain? Well, we look at this and we see that x is in the denominator of the fraction. And we know that we cannot divide by 0. So we know that x cannot equal 0. So I need to figure out how to write this in some sort of notation that the teachers will accept. So there are a couple of ways you can do this. You can write this as interval notation, or you can write this as inequality notation. So in interval notation, we would have, it can go anywhere from negative infinity up to 0, but not including 0, or it can go from 0, not including 0, up to positive infinity. And remember, infinity always gets the round parentheses, it never gets the squared bracket. So this symbol here means or. Or you can also use the word union, which is the more correct term for this. So that's one way of writing it. The other way is inequality notation. And I'm going to use set notation also, because inequality notation, I'm done. But using set notation, I would have the set of all numbers x, such that x is an element of the real numbers, and x does not equal 0, and that's done. Now, a lot of you will look at this and say, what's all that about? Okay? So instead of writing it in mathematical symbols, what I would expect you to do is to write this: x is a real number. Instead of all of that. So mathematicians, in a way, we're kind of lazy. We don't like to write as much. So we found a shortcut way of writing, and just writing those two symbols there is the same as writing out that whole sentence there. 3 symbols. X, element of reals. X is a real number. So that is what you would have to write. And I am going to make this look neater so you can tell more easily what I'm talking about. Because mathematicians are confusing too. So we have the set of all numbers, and that is a curly brace. X is the letter that we're using. So we have the x in the parentheses there, so we state that it's x. Then we have the bar saying that there are conditions involved here. Then we have to state what are those conditions. X has to be a real number. And I am going to use an abbreviation here and there. There's another condition, and that is x cannot be 0. And those are the only conditions that I have, so I close my set notation. Looking at the second one here. The name of the function is f. The independent variable is x. And that is my function itself. So this is almost like I were saying y equals 2x plus 1. Because it is in function notation, and because we have x listed as the independent variable, we know that yes, this is a function. So now we have to figure out what is its domain. look at this and I say, x is not in the denominator of a fraction, so I don't have to worry about that. X is not under the square root sign, so I'm looking at 1 over x. No. Is it square root of x? No. Is there anything else that we have that would limit it? No, not in this one. X can be any real number. So in interval notation, I would write this as open parentheses, negative infinity, all the way up to positive infinity, closing parentheses. And that is my domain. In inequality notation, using set notation, I would write the set of all real numbers, or set of all numbers, x, such that x is a real number. Close. And that's done. That's all that you can do. There's only the one condition that x has to be a real number. Looking down at this, y minus x equals 7. If I can make this look like y equals mx plus b, I'm set. If it looks like ax plus by equals c, I'm good. So looking at this one, that one looked like y equals mx plus b. So that one was good for that reason. This one looks like ax plus by equals c. So just have to flip that around. And I would make that negative x plus 1y equals 7. And yeah, that one looks fine. So this one, yes, it is a function. What is its domain? Is there any limitation on this? Do I have x in my denominator? No. Do I have x under the square root symbol? No. Do I have any other reason why I cannot say x is just any number whatsoever? No. So therefore, it's the same as that. My domain is x such that x is a real number. Looking at this one, again, can I write this as y equals mx plus b, or can I write it as ax plus by equals c? Yes. It matches exactly ax plus by equals c. So therefore, yes, this is a function. What is my domain for this? Is x in the denominator? Nope. Is x under a square root sign? Nope. Are there any other conditions where I have to worry about x can't be some number? No. So again, my domain is the same, x such that x is a real number. Done. Next question. Y equals 2. Well, x doesn't even show up in this one. So if I were to graph it, so I can do my vertical line test on it, there's my graph. There's 1, there's 2. Do my vertical line test on it. Nowhere on there does it cross my graph line more than one time. So it passes the function test. So yes, it's a function. Since it is a function, what is its domain? What can x be? This is one of those graphs that you should know. And x can be any number. So again, it's the same domain, set of numbers x such that x is a real number. X is any number. Looking at this one, I'm going to do my graph of it first so that you can see what it looks like on the graph, and we'll go from there. So I have my graph. I find x equals 4, and there's my graph. Now, this is one of those graphs that you should know. You should have this memorized, that this is what it's going to look like. Think back to my last lecture earlier in this day, this lecture group, and look to see, is a vertical line something that will pass the vertical line test? No, this one is not a function. Because if I were to draw a vertical line to do my test on this, my vertical line and my graph line are the same line. So it does not pass my vertical line test. Moving over to this one. X equals y squared. So if I were to try to solve this for y and make it look like y equals mx plus b or some other type of function notation type thing like that, I would be taking the square root of that and taking the square root of that. Problem is, when you take the square root to cancel the square out, you have to include both the positive and the negative square roots. Because we could say that we could have 9 equals 3 squared, or 9 equals negative 3 squared. So we would have the same number for 9 for x, and we have two different numbers, positive 3 and negative 3, for y. If I were to do a graph of this, drawing a graph, as I said, if I use 9 for x, so 1, 2, 3, 4, 5, 6, 7, 8, 9, I can use either positive or negative 3 for y. If I use 4 for x, 4 can be either 2 squared, or 4 can be negative 2 squared. So if I have 4, I get there, and I get there. And if I have 1, that can be 1 squared or 1 squared, negative 1 squared. So there, and there, and then there's 0. So the graph of this one is going up like that and down like that. Now, if I do my vertical line test on this, it crosses at 2 points. So no, this is not a function. So because it's not a function, I don't have to worry about what the domain is. Looking at this last problem over here, y equals x squared plus 2. You should already have been through finding out the graphs of quadratics, and you should recognize that this is a quadratic. This matches the form y equals ax squared plus bx plus c, where a is equal to 1, b is equal to 0, and c is equal to 2. Because this matches that form, we know that yes, it's a function. Next thing I have to figure out is, what is its domain? Is there any limitation on what x can be? Well, then I have to ask myself, is x in the denominator? No. Is x under a square root symbol? No. So again, x is any real number. And this problem is done.